Hello, welcome to another episode of Data in the Hallway. My name is Ray Paik, Community Manager at PingCAP, joined by my co-host, Daniel Van Eden, beaming in from the Netherlands. How are you, Daniel?
Good.
Good afternoon for you. And yeah, it's an honor to have our guest today, Sijie Guo, the co-founder and CEO of Stream Native. And I think we first met last year in San Francisco during the Pulsar Summit, and then I kind of cornered you, and we'd love to have you on our podcast to talk about streaming data. It's finally great to have you. I think thanks for your time and coming on.
Thanks, Ray. Thanks, Daniel. Thank you for having me here as a guest.
Yeah. So, I mean, so you are not just a co-founder of Stream Native, but I think you're one of the persons that got Apache Pulsar started. So I love the origin stories of many open source projects. So tell us about how, when Pulsar got started and how it got started and who you started working with.
Sure. So for people who doesn't know what is Pulsar at a very high level, it's next generation cloud native data streaming platform. It was originally built at Yahoo by a bunch of talent people. I work with my co-founder and CTO, Matteo Murli, back in Yahoo about 10 plus years ago. We originally were tasked on building an internal services called cloud messaging service. So the concept of the cloud messaging services at that point at Yahoo is that there were so many different business units are using different messaging data streaming platform technologies, including RabbitMQ, ActiveMQ, and also Kafka was born around that time, and some teams are already start exploring it. But the challenge for large enterprises like Yahoo is that there were so many different teams has been kind of using different technologies, and the operational complexity and also data has been kind of segregated across different business units. They are not able to kind of share across teams. So in order to kind of improve the operational efficiency and also consolidate all the resources into a centralized platform, internally we call it kind of a messaging cloud. And that was the kind of the original motivation of goals of building out the entire cloud messaging services. And that project was running at Yahoo for a couple of years before it was open source. And that has been kind of supporting more than hundreds of business applications within Yahoo and deploy across 10 plus data centers globally. It was a kind of a production proved before it was open source, very much like the other projects that Yahoo open source before, like Hadoop, the entire big data ecosystem. Pulsar was taking a similar route on validating within Yahoo and then growing the usage of Yahoo, and then to a certain point, then we feel open source it and let more and more people adopt it, use it, is able to kind of supporting the entire project and is able to kind of benefits to a broader kind of a data streaming ecosystem. And that was why Yahoo and we decided to kind of open source that technology around 2016. And that was the kind of the initial story on how it was born and how the project was contribute to the Apache Software Foundation, and that leads into the growth of the Pulsar community, and eventually leads into the creation of Stream Native there. Yeah.
Cool, nice. So, I mean, this might be a dumb question. I mean, a lot of our listeners and people who watch us on YouTube are obviously interested in database, but how would you define what streaming data is?
Yeah. So I think that's a really good kind of question. Sometimes I think data streaming is definitely kind of much newer kind of concept. I think 20 years ago, I think people more know about the concept of messaging queue, messaging bus. It has been using as a queue between for asynchronous communication between different services, between your front end server to your back end services, to decouple the kind of services to improve reliability. But the concept of data streaming was more kind of a rise probably like 5 to 10 years ago, and mostly get started from the kind of the high-tech companies adopting data streaming technologies for doing some of the event-driven architecture or stream processing, stream analytics to react to events arrive at real time. That's kind of a high-level concept, but usually I talk to people who coming from databases are usually using a concept called database is designed for what usually we call static data. So you your database is keep updating, and you would issue a certain query to query the data. That is more like a database. But data streaming is more like you're building a database, but more for emotion data. So meaning the data is flowing into the entire system, and you are taking actions when data arriving into the system. And the type of queries that issue into the system is usually what we call continuous queries, rather than in quite different from relational databases that is you doing ad hoc queries, or you write any you might be experiment different type of queries and try to get different results. But streaming in the streaming world, the type of queries that you issue usually a fixed pattern, but the query is fixed, but the data is kind of continuous flowing through the queries there. So that's kind of the concept there.
Cool. No, I mean, that really appreciate the background. I think a lot of the technology terms and jargons get thrown around, and then people, I mean, I think it's good to sort of step back and really understand what it is, especially from people like yourselves who's been working on data streaming for a long time, because people have this perception of what data streaming or what something else is, but if you really think about it, you're just sometimes you're just scratching the surface. So I think that background like definitely helps.
Yes.
So go ahead, Daniel. I think you're about to say something, but
Yeah, I also think with data streaming that people sometimes think that it's the same as queuing, which is not always the same, but it might be similar. So sometimes like terms can also be confusing because things are similar but not the same.
right. Go ahead, CJ.
Yes, I think I kind of 100% agree with Daniel. Is I think queuing and streaming usually some word are kind of confused terms to people. People might view like especially taking Kafka as an example. I think originally Kafka was kind of more market as a messaging queue, but in like under hood is actually a streaming, because streaming is more looking into okay, you sequence a bunch of the data in order from a service A to service B, and what has been kind of really care on data streaming side is the kind of the order of the event within a stream, and the type of actions usually taking in over a stream is that we will do looking into a windows of events and then do taking certain actions over the windows there. But queuing is in contrast is still dealing with emotion data. You're kind of flowing the data from surface to surface B. But the way how your consumer or your workers consume the data is quite different from streaming. Is that queuing just focus on individual events, and you take an event from a queue, process it, making sure the event is it's being processed, and you will never deliver to another kind of another consumer to process it again. And so that two different type of concept usually meaning two different type of workloads there. So doing typically are using more in I would say transactional OLTP type of workloads. There is that you would be, for example, like payment processing, order processing, sending notification workflows. You are taking this individual actions event and making sure that event is processed exactly once. In contrast, the streaming is more using for data transform from moving data from service A to service B, or even sometimes doing what we typically call replay capabilities, that I want to rebuild my certain state, then I would kind of roll back to kind of earlier position to replay the entire data stream. So that is more capable for doing like log ingestion, data streaming pipeline, event sourcing for kind of building the entire concept. So slightly different, but it's also kind of this is a good question to kind of tie back into a broader kind of concept that we discussed kind of in the previous meetup that we co-organized between PingCAP and Stream Native, is the concept of hybrid transactional and analytical workloads. Queuing is more kind of working in the transactional workloads, while the data streaming is more used in the kind of analytic workloads there.
Yeah, no, yeah. I mean, yeah. Thanks for you sort of preempted my next question. We about the meetup we had. I guess it's already been like a little over a month ago. The summer's going by pretty fast. Yeah, because I think you and your team reached out to us about doing a joint meetup, and you brought up HTAP. And HTAP, obviously that's something us at PingCAP have talked about for a while, because we have. For people that are not familiar, HTAP stands for Hybrid Transactional and Analytical Processing. It's a term that was coined by Gartner about 10 years ago, I think. And then I think it's almost entirely been used in the database context, right? So, and then, since, our TiDB database has some HTAP capabilities, even our summit's called the HTAP Summit, which is coming up soon. You wanted to talk to the communities, both of our communities, about HTAP. So I kind of tilted my head and go, that's not something that I expected. But I think, like even your presentation talked about like in the modern data stack, these silos are becoming problematic, and these are like a new challenges that we need to get beyond. So yeah, I mean, tell us a little bit more about that, and maybe you're recapping what you talked about during your presentation, but talk about challenges with modern data stack and how even like outside of the pure database realm, you're seeing this as something that's happening in the modern data stack. But
yeah, I think that's definitely a kind of interesting kind of observation across all the kind of modern data stacks. It's not just happening in the database world; it's also happening almost kind of every pieces within the kind of entire modern data stacks there. So in using kind of PingCAP as an example, is that the entire concept of HTAP database is that you're using certain replication mechanism to making sure some copy of data is being stored for serving transactional workloads that is more or less care about the individual transactions, so you can get the transaction in much quicker, and usually attach kind of a single row or maybe a few rows. But in contrast, you would organize the data in columnar format that is designed for these analytics workloads that usually would touch, I would say, majority of your data set on kind of maybe doing aggregation, analytics, or even probably, I think last time you also mentioned you're probably looking into some sort of vector database, vector search capability there. So those kind of the concept in the HTAP tab, I think, is using one copy of data serving different type of workloads, and be able to kind of enable data sharing between your, I would say, user application, and as well as your analytic workload without introducing complicated data pipeline to maybe doing ETL to read data from your OLTP database and ingest to your OLAP database. So that's kind of animating the complexity. So that's the entire concept of HTAP, is really using one copy of data to enable data sharing across transaction workload and analytic workloads. And we see similar things that is happening in the data streaming side. Using queuing and streaming as an example, is the queuing typically are using as a asynchronous communication layer between microservices. They're moving these transactional business events from service A to service B for communication. But all these business application eventually would generating business events. And those events would eventually putting through, I would say, data streaming pipeline. And that data streaming pipeline, you probably attach certain processing capabilities, you would write a function, register a function. When the event comes in, the function will be triggered and do some extra work. You might be writing a Spark streaming job or Flink job to processing those real-time streams. And last stage of the entire life cycle is that the entire data streams would be eventually be pushed into some sort of data lake or lakehouse for archiving. So if you're looking into the entire life cycle of a business event, it gets started from your business application, going through some sort of streaming data streaming pipeline, and eventually land in lakehouse. So there's so many different steps into the entire life cycle. And the problem of this is the data has been kind of developed in different technologies, that you have different schemas that is existing in different systems, and you need to build in different type of connectors, integrations on connecting this system together. And this is a very, I would say, time consuming, because you need to operate in multiple systems. And secondly, it's error prone, is that you need to manage the schema mapping along the pipeline. So that means if any errors come pretty late into the entire pipeline, it's really hard for you to capture those errors and dip into the pipeline. So the entire concept that is happening in data streaming side is what we call shift left. Is if you're moving the entire integration points towards the entry point, then that means your producer producing the data into a data streaming platform, we will validate the entire schema, making sure the data comes in is at a good quality. And next, you are able to reuse the same copy of data for queuing, for streaming, and for ingesting the data into lakehouse. Then that will solve the entire complexity of problem of the long chain of the life cycle of events. So that's kind of the concept of what we see is what happening in the data streaming world is that the unification of queuing and streaming is really coming into one platform. And that is allow people to store one copy of data and using the right consumption model they need for building either their business application or their streaming data streaming pipeline, using for like streaming analytics. So very similar route as databases, how database is evolving, but more with the same principle that HTAP database is looking for, is storing one copy of data and use that copy of data to serve different type of workloads. And similar thing is happening in the machine and data streaming world.
Go ahead, Daniel, sorry. Yeah.
One other thing that might be interesting to our listeners is that there's data streaming, there's TiDB, but these two come together with TiCDC, because our TiCDC product allows you to send data in different streaming formats, including Pulsar, Kafka, and more, directly from the database. And then, like, other applications are able to consume these streams.
Yeah, I think CDC in general is a very common. I would say, um, I don't have data, but I'll probably guess it's one of the top five use cases that people use data streaming for. Is CDC is usually kind of capture the changes that is happening with databases and turning a database from a table into a stream, and that stream can be used for either replication for moving replicate data from one databases to the other database, moving from one location to the other location, and also maybe attaching certain like streaming processing logic over the CDC there, so they can react to changes that is happening within the change stream of database. Yeah.
Yes, thank you.
Cool. Yeah, I think we have like a page on documentation about like, connecting with Pulsar. So we'll include that as well, and for people that are interested. But yeah, I mean, we do get questions like particularly like on our Slack about integrating with like working with Kafka and Pulsar from like TiDB. So this question does come up, and yeah, I mean, it's pretty interesting. Like maybe HTAP term will go beyond like a databases soon. Like what like you mentioned, Sijie. So who knows, right?
Yeah, who knows? Yeah, probably it could be just called a hybrid transactional and analytic storage. I mean, streaming is storing streaming data. Database is storing kind of relational data, static data. So it could be just using a generic term that is more like a storage. So yeah.
Yeah, no, I think this topic when we had this meetup in June was somewhat timely because it was shortly after both like a Databricks and Snowflake's folks had their own big events. So like data lakes and data warehouses were big topics around that time. So yeah, it was a fun meetup, and
Yeah.
yeah,
We hope to do more with you guys.
yeah. No, I love like this is like I've done a few meetups, and it's always fun to sort of join with other open source communities. And then I mean initially you don't think there'll be like a connection between the two, but I mean any like a high tech communities you can always find a connection, right? That's what makes it kind of fun and interesting. So yeah, cool. So. Uh, uh, I wanted to sort of like go back to sort of the origin story. Like, why did you decide to start a Stream Native company after you started working on Pulsar? And I'm sure like you're still active in the Pulsar community as well. But what was your motivation for getting Stream Native started?
Yeah, so I think originally, I mean, I'm a system infrastructure engineer, tending founder. So in my I would say the our motivation as an engineer usually is I build a great software, and I see how this software helping large internet company on getting a lot of values. So we all have a vision is that we want our software that is able to kind of deliver to more and more enterprises and be able to kind of helping them solving their real-time business application challenges there. And that was why we open sourced the entire project and contribute to the Apache Software Foundation. But at the beginning, I don't think we have idea of kind of creating a company, but more like we want to see how the entire technology can helping enterprises to solve their problems. So from like 2017 all the way to late 2019, we have been kind of more focused on building a community, growing the adoption of Pulsar technologies there, and we did kind of a lot of community activities at that point, working with different adopters. So we have almost, I think, every month we have a meetup with different users who are adopting pulsar. And at that time, I think in 2019, we start kind of looking into the concept of pulsar summit. And at that point, we find pulsar already growing into a pretty large community. At that point, I think almost top 10 like internet companies in China, they are using pulsar, and we also have a bunch of the high-tech companies in the US adopting pulsar. So the community is kind of growing towards more like a global community across APAC, North America, and Europe, and we find that is a lot of people in the community is asking, is there any managing services in for pulsar? At that point, I think there's no one providing managed pulsar services there. We know this is a kind of signal, meaning there's a need in the market. People are looking for some sort of managed services for pulsar, and that cannot be done by just a pure community. That need to be backed up by a commercial business. So at that time, we decided to kind of found the company, create Stream Native, and the idea is that if people love the technology itself, that means we are helping people to solve their business problems. And in order to continuing backing up the project and making sure more and more people is able to enjoy the benefits of this technology, a commercial product, a commercial company makes more sense. And then we found the company in around late 2019. I would say it's a COVID company, so it started around kind of when COVID started. Yeah.
Cool. Yeah, I mean, I appreciate that. And then, yeah, like I said, I first met you at the Pulsar Summit last year. Was, you know, pretty impressed, not just with the presentation, but the community and the interaction with the community members. So, yeah, I mean, I think I mentioned it earlier. You have another summit coming up in, I believe October of this year.
October, yeah.
Yeah, I'll add happy to include a link to that event if people want to go check it out. And I think it's like a similar location in San Francisco, right? It's like very easy to get to. So yeah, hopefully, you know, we'll get to see some of our listeners there. So cool.
Yeah, actually, one thing to call out is that this year we kind of do a kind of major upgrade to the conference. So we kind of rename Pulsar Summit to Data Streaming Summit. This is one of the changes that we found is we feel Pulsar itself is growing, but at the same time, there's still tons of the kind of Kafka users that is experiencing pain points of using open source Kafka or different flavor of Kafka. And we, as part of community, also as part of Stream Native, we have been kind of working on Kafka compatibility over years. And that would feel from a technology perspective, from a conference perspective, we should not limit ourselves to just Pulsar itself. There's so many different data streaming related technologies that including Pulsar, Kafka, and as well as some of the stream processing technologies like Spark, Flink, and people are using different technologies for building out their entire data streaming journey. We hope the change of the name and the upgrade of the event will kind of attract more people from the entire data streaming ecosystem can coming in to talk about different technologies, not just Pulsar itself. So we hope this will be kind of a big change from the event perspective. And another thing I want to call out for this conference is that our entire theme is about data streaming for AI plus AI. We're not just looking into data streaming itself, but we want to see how the entire data streaming infrastructure can be used for either accelerate your AI adoption, how AI can also help in data streaming to improve the entire either user experience, quality, performance. So then we are kind of looking into how to data streaming and AI can come together and maybe generating some of the crazy ideas from different users, commuters, and as well as vendors to talking about data streaming, including AI.
Cool, cool. Yeah, I mean, I didn't even know about the new naming of the event. That's yeah, I think it's very appropriate. That definitely makes sense. So, and yeah, looking, I know, I mean, few of the PingCAPers in the Bay Area will be making up there too. So we look forward to seeing you there. Yeah, I'm just going through the list of my questions. I think I covered everything I wanted to ask. Like, Daniel, do you have anything else or like
No,
good?
no, for me.
All right. Well, CJ, so it's time for our last question. And this is sort of our tradition that we ask all our guests to talk about the areas they live in. I think you're like the fourth or fifth guest that we've had on from the San Francisco Bay Area, ranging from Foster City, like Fremont, Sunnyvale, and other places. Like, tell us where you are and tell us about your favorite places that you
Yeah.
like in the Bay Area. So.
Yeah, my first time I kind of moved to the US, I came to San Francisco. I lived in San Francisco for about 10 years, although like about 4 years ago, I moved out of San Francisco to East Bay. Living most of my time is in East Bay. We have office in down in Mountain View, so I probably go to pretty much everywhere in the Bay Area. But if it's speaking the most favorite places in the entire San Francisco Bay Area, I still think San Francisco is a pretty good city, and I like there's a place called Land's End, and that it's close to the Golden Gate Bridge, and it's just right by the sea, and it's a very beautiful places, and there's a really great trail. But you should come to that trail in a pretty sunny day. Although I think most of the time in San Francisco it's kind of windy, cloudy, and don't recommend you camp around that time. Camp on a sunny day and hike the Land's End Trail, and it's a pretty amazing. Yeah.
Yeah, well, thanks for sharing that. Yeah, I mean, I think that's one thing people don't realize. There are a lot of actually good trails in San Francisco. Weather is
Yeah.
sometimes a challenge. One tip I would offer is that August tends to be actually the worst month in terms of fog. So you want
Yeah.
to I mean, that's pretty unusual compared to other places. Like July and August tend to have the best weather in a lot of places, but that's not the case in San Francisco. But yeah, I mean, Land's End and other hiking trails in San Francisco, yeah, those are a lot of good hidden gems there. So
Yeah.
cool. CJ, I mean, thanks for coming on. Like I said, I cornered you while you're so busy with things at your summit last year. Glad you came on, and yeah, I mean, it was definitely a fun meetup a little over a month ago, and hopefully we can do more in the future in the Bay Area. So
Yeah. Same
cool.
here. Looking forward to more
Yeah,
meetups, webinars, or whatever cooperations between TiDB and pulsar and PingCAP and StreamNative.
yeah, yeah, definitely.
Yes.
Looking forward to it. All right. Thank you.
Same here.
Yeah,
Thank
have a
you.
good one.
Bye.